In this video, I will discuss enzymes and their importance. So enzymes are specialized proteins, very large proteins, and their job is to increase reaction rates by lowering the activation energy it would take in order for that reaction to happen. They break down substrates to create products. Let's talk about what happens if you are missing an enzyme. So the reaction would take place, but it would require a lot of energy and a lot of time. And so for some of those enzymes that we are missing, we don't have that time or that energy. So let's talk about lactose. Lactose is a sugar that is found in milk, and for some people, it's also found in a lot of other dairy products. For some people, we don't have the enzyme lactase in order to break down the lactose. Lactase is found in our small intestine, and when the lactose reaches our small intestine, if we do not have that particular enzyme, it cannot break down this sugar, this disaccharide. Our bodies can process glucose very easily, and that's what lactose is made up of. It's glucose and galactose. So it's reached our small intestines, and if we are missing lactase, it moves on to our large intestines. Now, inside of our large intestines, we have bacteria. And the bacteria will then feed on the lactose that has not been processed. And that causes a whole slew of side effects, such as gas and diarrhea, bloating, stomach cramps, which is very unfortunate. So how does an enzyme work? An enzyme works by having particular substrates bind to it and creating products. So let's go through the steps. Here's an enzyme. And this spot right here is called an active site. This place is very important. This is where your substrate, let's pretend this is our substrate. Okay, so our substrate is going to bind onto an active site. This is called an induced fit. The enzyme almost hugs the substrate. And there are particular substrates that will match particular enzymes. So they go hand in hand, like lactose and lactase. Once the substrate has bound to the active site, it then breaks the substrate apart and you get products, which, as I mentioned before, would be glucose and galactose. In some instances, you could have inhibitors that would either sit here and block the active site, or you can have an inhibitor that is on the outside of the enzyme, which changes the shape of your active site and no longer allows the substrate to bind. Something else that I want to talk about with enzymes is optimal conditions. Let's erase this here. When you have an enzyme, it needs to work in particular temperatures and particular pHs that it is comfortable with. So, for example, an enzyme found in our body will work much better at a body temperature than a colder temperature, whereas an enzyme in an apple might work better in colder temperatures than body temperatures. You also have pH. So there's optimal pH for an enzyme. The optimal pH of an enzyme found in your mouth, such as amylase, is very different than an optimal pH of an enzyme found in our stomach, like pepsin, and that breaks down protein. What happens if you have a temperature or pH that is outside of that optimal range? It would slow down the amount of product that is produced. But if it's completely out of the range, right? So it's very, very acidic and it doesn't normally live in an acidic environment or basic. Or if it's a very, very high temperature or very, very low temperature, and that's not what it is designed for, this would denature your enzyme. This would alter the active site, and your substrate would no longer be able to bind onto that active site, making it not able to work. All right, I hope this helps.